This conference will now be recorded.
Okay, so now, yesterday I might have last session I might have told you what is Docker. So basically, when I say Docker, and I'll be little fast. So if you don't understand something from me, then you can stop and ask for repeat. Okay, Anush?
Okay, sure.
So what is Docker? So simple way, let's not complicate. It's a container management tool. Now next question is what is container? So container basically is like a lightweight. Okay, it's a lightweight application runtime environment. Okay, so in a simple way, I said lightweight means when I say lightweight means consume less CPU, less RAM, and to in order to run applications compared to the virtual machines. So earlier we were running a application in a physical server, right? Then we
Correct.
migrated to the virtual server, and then now we are running a container. So basically, physical servers, we were consuming lots of CPU, lots of RAM. It's basically not consuming, I would say, wasting. And with the virtual servers introduction, we stopped wasting that one. So that
Yes.
now what to do? So here, if you see the virtual server, there's only one thing which is a problematic, which is like let's say you want to have a five applications, okay, five applications. So how many virtual server you need? Five virtual servers. Why? So you will say, no, I need availability, reliability, this, that, all these reasons you will say in the production server. So what is the drawbacks of five apps, five V virtual server? Then you have a five operating system also, right? That is
Correct.
a problems here. So this operating system also consumes CPU, RAM, and hard disk. So how do
Yes.
we go about it? So now, very simple thing, which I don't know where I covered or not. Let me put it up in this way. So here, this is the hardware, this is the operating system, and then after that, this is the user. So I'll talk about this is the root file system, this is the network, and this is the PMAP process map. And then we have a multiple user. So here there's a user, okay, and there is a
Mhm.
user, there is a
Mhm.
user. So this is the traditional model, the one which you are right now. So this guy is also running Apache. So this guy cannot run Apache. Why?
Correct.
This guy also cannot run Apache. Why? Because
Because
80
of
port 80 port is you are consuming, C Apache you are consuming, and the
correct.
PID is 50. So this guy cannot have a same thing. So what we did, this is not possible, this is not possible. So what we decided in the production, we'll run the virtual machines like that. We'll run only one user, one application, and all the resources. Make sense?
Yes, sir.
So
But the
here,
question is, but the question is, I mean, like maybe I'm wrong, but I want to clarify. For example,
hmm,
I have a virtual server.
hmm,
Are you talking about my server or just a
virtual
normal
server,
instance?
virtual server.
Okay. Virtual server, for example, I do have a SQL server installed on it,
Hmm,
and we assign users to that virtual box, right?
right.
But and I can use the SQL server, and other guy can use the SQL server at the same time.
Mhm. Yeah, but you are
So
not thinking at the data center level, no? So data center, when you have, let's put it in this way. So here I'm just giving you simple state. This is you.
mhm,
You have
mhm,
laptop. You hit the www.devopsschool.com DNS to load balancer. When you send the load balancer, it will only load balance the similar app. So here one VM, two VM, three VM, four VM, five VM, and each one of you have a Apache. You can't have MySQL here. Okay, so this is the web stack.
okay,
After that, again we have load balancer, and again we have something similar VMs, but for the backend like web server, like the database server. So here, what we want the similarity of the applications. You can't say, okay, I will set up a database here, and then from here you will call this one. So in the production, it will create a lots of problem in terms of managing the infrastructure because you
okay.
don't run one or two machine, right? You can
Yes,
do anything in a laptop, but in the production you have thousands of servers running one application.
correct.
So that way it's become very difficult. So what we have, so In this case, we have a container. So what is a container actually? So you are also container actually. Let me show you the task manager. Here, if you see that, look at this task manager.
Okay.
And if you look at it very carefully, it's a Windows Linux almost same. If you look at it very carefully, this is one application, registry. There's one
Correct.
more applications. And if you see that there's a PID, and if you
Yes.
see that this is a user, and there's
Yes.
some CPU allocations, memory allocations. So that means if you see that every user, every application, you need a one user, one
Correct.
PID, some
Correct.
CPU, some RAM. So all these things you need it. Okay, correct?
Yes, sir.
So like that. So here what is happening? Nothing great actually. Let me put it up in this way. This is your operating system. Okay.
Okay.
And on top of that, you have a root file system here. Now, operating system, you have a kernel, okay, and kernel we have some library. Which library? Let me show you. So Docker,
Namespace.
yeah,
Name.
Docker namespace, and see this is the library. Okay, so here what happens? What happens? These are the libraries: C groups, namespace, net. So all this thing you have it. So kernel you have all the namespace. Now here, how many root file system you have? Only one. How many
C.
network you have? Only one. How many PMAP you have? Only one. And then you create a n number of users here. So here
Yes, sir.
technically you can have one multiple users. So you can have a multiple root file system also, multiple network also, multiple feed ID also. So what exactly happening? That is where the Docker is coming on top of it. Here somewhere Docker is coming here.
Okay.
And Docker is saying, hey, I will run as an application. So everyone say, yeah, run. What's the problem? You can run. Everyone is running as applications. Then Docker says, hey, I need to access your kernel. So Windows said, no, 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 I will not allow to access kernel. This is the Docker, okay? So Linux said, yeah, you can access it. Some of the libraries are available: libvirt, lxcs, systemd, spawn. You see that image? Yeah.
Yes, sir.
So these are the libraries are available. You can access the kernel. Then this Docker said, can I create a one root file system? So Linux said, yes, you can create. That's not a problem. I have created only one for the operating system for the users, but you can also create, because you can create as many root file system. So they said, can I create one more network and one more network? So Linux says, yes, you can do that. So capability is available. Then Docker said, can I create one PID also here and here? So Linux said, yes, you can do that, because it's library. Just initiate that library. That's all. So they said, Docker said, can I create one user of space also? So Docker said, yes, you can create as many users here also, user. So you can create all user. The only difference is, then Docker said, hey, I don't want to add this user with this root file system. What I want, this user, I want to give separate resources, separate resources. That means all these resources got attached to this user, all these resources got attached to this user, and this user is root file system, network, feed, and user. And here you have applications. So that means, you see that applications can run independently without having any dependency. So here you are running Apache, here also running Apache. You are running 80 port, you are using this network. You are using the 50 PID, you are using this PID map. You are using the C Apache or OPT Apache here. OPT Apache 80 port, 50 PID. All are similar now. Why? Because this common resources now is not being used by these users. Now this
Correct.
whole environment is called container. That's it. So here if you see that there is no operating system, this is still running on this. This is also still running it with the help of Docker. So that's the reason I said Docker is a container management tool. Make sense?
Yes, sir.
Okay, so now we have understood that. By the way, let me tell you here, I have a 2 hours of explanations on YouTube only for containers. So you can check it out. Got it?
Okay.
So in detail way, it's pretty book. Just check it out if you have bandwidth. You can. Okay. So now this is the Docker, this is the container. Now how do we install it? So this is the one machines which I'm having, which is on cloud. So Docker is installed. Okay. How do we install? Let's say you want to try it out install. So I share with you last day instructions. Docker install. So you can follow this instruction. There is no other document section. Last day some mirrored issues are, I don't know what kind of issues which wasted our time. So this is the things which you can follow. 3 methods are there, and you can install Docker. Okay, so now you can install Docker using this. Now next thing is, okay, fine, I installed the Docker. What to do? So guys, you need to know 4 components. Which component? One is Docker engine. Another one is Docker engine. And then Docker images. Then Docker container. And Docker registry. So you need to know 4 different components. Now what is the engine? So that installation of Docker engine, the moment you install the Docker, no? So you will get a Docker client. Docker client. Let me put it up in a simple way. Client. Then Docker D. And then container D. And then here kernel. So here what is happening when you install the Docker? These are the things you get it as a part of Docker engine. Got it? When you install this Docker, you get the Docker engine. So which is the client? Let me show you here. So here, which Docker? This is the client. Which Docker D? Which Docker D? This is the daemon. Which container D? These are the locations. Okay. Now it's running or not? Let me check this. Docker D should be running as a daemon. See here, it's running. Container D also should be running as a daemon. Container D. Okay, and container D talk to the kernel and stuff like that. So this is the software installed it. Make sense?
Yes, sir.
Now what is a Docker registry? So let's say you create a VM. Yesterday you created a VM. For that you will need ISO image, right? Correct, no?
Correct.
When you create a Vagrant VM, what do you need?
I also need an ISO, but
Image.
from it, yeah.
Not ISO, it's a box we call it, right?
Oh, yeah, correct. Yeah.
Yeah. So it's the image itself, OS image, but it's in a format of box. So
Okay.
something similar concept we have in the Docker registry. So Docker registry, is a place where you can find a lot of repository. Okay. Multiple repository are located at a Docker registry. Now
Yes.
repository is equal to image, Docker image name, simple. Whenever, see, technically we call it repository, but for the human being it's a image name. So what is the image? So image is nothing but repository contains version, mind it, version of file system. Now we'll say what is a file system. So understand this way. In the VM image, you have a different kind of file system. One is a boot file system. Boot file system means it's a kernel. Then we have a root file system, and then we have a user file system, and then we have a next one, which is we have application file system. So now boot file system is your kernel. Root file system, you want to see that? Look at this.
It's drives.
Yeah, start with the root. Okay, this is the one. See, everything start with the root. That's called root file system. See here, this is a good image. Got it. So user file system, let me show you clear. Whatever you see in the my user home, it's called user file system. This is my user file system. In Linux also, whichever user home. And if you want to see applications, most of the applications I deploy in C tools. So I'll go to the tools locations, and here this is the Apache file system. So in the VM image, you will have all 4. But you know what? Docker image, you have only these 3. Yes, these 3. So that's the reason I said no. Container is not having operating system. Why? Because it has not a boot file system. Make sense?
Yes, sir.
So here Docker image has a root file system, user file system, application file system. So here if we want to some examples. So here when you say Docker image, which is having only root file system, so that we call it Ubuntu or CentOS or Fedora. Then you will say Rajesh, now you are calling the name of the operating system. So actually you need to understand that kernel is there is only one kernel which you call Linux kernel. On top of that, using the Linux kernel, everyone have written their own flavor of Linux. So that exactly they change the root file system, not a kernel actually. So they change the root file system. Whatever you see is a root file system. So Ubuntu is a one of the flavor of Linux, but actually it's starting from the root file system. So if you go to the Docker registry, let me show you. Docker Hub. This is one of the popular registry from where you can download the image. Okay, a lot of lakhs of images are there. You see here. So here, if you see that there is a one, oh, there is one image Ubuntu. So Ubuntu is a root file system. Okay, and then user file system. Then you can have, let's say Ubuntu. You are running Jenkins. So Jenkins is user, and then you have a application called Jenkins, like this. So these three file systems will be having the image. Now if you see that HTTP image, that means it's built on some root file system. MySQL also built on some base image root file system. Are you understanding?
Yes, sir.
So the question was from where we get the image. So hub.docker.com is a registry. There we have a repository. This is the name of the repository. And inside this repository, you have versions of files. These are the versions of files. Okay, is called file system. So here the question was, you need to install the engine, then you need to download the image from where? Docker registry. How do you download? See here, pull. And after that, you have a image nothing but which I discussed right now. So here you can get a download of the image, which is image. And the moment you run the content, the moment you run a image, it become a container. Simple. Got it?
Okay. Yes, sir.
So, so all the
Let's
other
let.
resources like CPU, RAM, and all, it get attached to the container, and then applications you can browse it.
Okay. Do you want to show the steps, or you want me to look at that video?
No, no, no. I will show you that step. Okay, so now next thing is every time we have a some workflow life cycle. What is a
Mm-hmm.
container life cycle? Okay, what is a container life cycle? So in the VM, what you did last day, VMs.
We set it up, turn it off whenever we don't need it.
Let me put it in the right way. You created a VM, correct now?
Correct, sir.
Then you started the VM, then stop the VM, then start again, then you can restart the VM also, and then pause the VM, unpause the VM, and then stop the VM or kill the VM, and then finally remove the VM. So these are the things you do with the VM. So with the containers also you can do the simple similar things. Okay,
Okay.
so container lifecycle. So how can I do that? So let's go for here. Go for first how many images I'm having. Let me check. So Docker images. I'm having 3 images. I don't know when I got it. Okay, so I'm using one of the production server. Okay, so this images we got it long back. Okay, so what you want. So let's say start with work with HTTP. It's there. So HTTP is one of the image, which is like a web server, easy to learn. Here it is. Okay, so Docker pull and HTTP. So here I pull this
So
and it's
when you have it, why are you pulling it, sir? To update it, or?
so I told you, no, this is a, I think I got it 5 minutes back. Okay,
Yeah.
so I am updating it that one. So let's see that when it was last created. So here 13 days ago. So this is the updated one. So the last one got renamed with something else. So
Yes.
I'll do one thing just to avoid the confusion in you. I'll delete that image. Okay, so now you have image. Now each image you have a name that's called repository name actually, an image ID, that's unique, the size of it. So yes, how many containers I'm having? Docker PS, you see no container. How many containers are exited? So these are the containers got exited. I don't know why I created this container. It is a 4 months ago. So it's okay, no problem. So right now PS command will tell you running container. PS-E command will tell you running and plus exited plus created and all this stuff like that. So these are the commands you have to remember. Now what to do then? I am going to do this like container lifecycle. So can I create a container here? So yes, I want to create a container. So Docker images, Docker create command. Which image created? Guys, I created container which is not running, but you see that this container is created. Each container will have a container ID from image running with created and dot. This is a unique name. You can use the unique name or container ID, both will work. You can name it also custom way. So container is created. Container, just like a VM you create, container is also created. Nothing, no deal. Now how do we start the container? So Docker start.
HTTPD.
No, this container ID.
Okay.
Image name is HTTPD. Container ID or name of the. Now see here, it's running only one container. Up
Yes.
to second. So here I got this created, I got this top. So I'll do one more thing, create one more container and Docker ps-uc. Docker ps-u. So see that one of the container I created, one of the container I'm running. This container is just ignored. Okay, so now can I stop this container which is up? So Docker stop container ID, and you see again it will get exited. See. So this container got exited. So now I did create, start, stop. Can I start it one more time? Let's do that. So here I am going to start all container. In fact, Docker start. I don't know how much CPU I'm having in this machine, this production machines. It's okay. And all containers I'm going to start. One container ID you can also give it, but I give it all containers. By the way, few containers did not start it because of some reason. Okay, because of this is the duplicate containers using the same. So yes, no problem. So this container I'll delete this. So Docker rm. Yeah. So now you see that I started all the containers from the space. All containers are. So guys, this is the starting. Can I restart some of the containers? So Docker restart and this container ID enter. And you see here up 1 second because I restarted. Last time it was 26 seconds. So can I pause this container? So Docker pause and container ID. And here you have, see, this container is paused. Now you'll ask me, Rajesh, what is the pause, meaning of pause? So this is the assignment for you. Okay, what is a pause and pause? This is the kill. Can I kill the container? So look at this here. Duplicate command. Docker kill. This is the command which is running here. And you see that when I kill exited. So when you stop the container again exited. When you kill the container again exited. So what does that mean? So basically you need to understand what is the meaning of kill versus stop. You have to tell me. Pause versus unpause, kill versus stop. So can I unpause this container? So unpause this container which is paused from long time. Unpause this container. And you see that. And finally, can I remove the container? So here my work is done. And here in this Docker RM, I'm trying to remove the running container. It says no, you cannot run, you cannot remove. So I have to remove only the exited container. So I should stop all the containers and then remove. See that is gone. So these are the workflows which we follow. I mean, life cycle. Create a container, start a container, stop the container, start the container again back, restart the container, pause the container, and pause, kill and remove. Did you understand that?
Yes, sir.
So it's very simple, and These are the commands I try. Though try with your own logic and it'll be easy. Okay, any questions so far?
No, I'm good, sir.
Okay, so now next thing is, okay, fine. You work with the container, but how to use it? Correct? No? How to use it? So when you run the VM, what you do? When you run the VM, what you do? Either you go inside a VM and then do something shell and all kind of things, right now,
Correct. Correct.
and or access from outside using HTTP, correct?
Mm-hmm.
Right? HTTP, some
Yes, sir.
applications run. So now the question is how to go inside this VM, this container, sorry. So you have a container running? Yes, I have a two container running. So here you see this is the container and this is the container. So how do I go inside that? So there's one command which is called docker exec. So docker execute -it. IT means interactive way. Which container? This container. You are the human being. So what do you need? Shell. So inside a container, you are going to execute the shell. See here. Where are you running? Where are you running?
1 second.
Yeah. Where are you right now?
I am in the root folder.
Nope, nope, nope. You are inside a container. Mind it.
Okay. Ah, yeah. Yes, sir. Okay. Bala. Yeah. Okay.
Exit. I'm in the VM. I'm inside a container. I'm in the VM. I'm inside a container. ls c root file system. Exit c root file system. Got it?
Yes. Yes.
So yes, you can go inside a container using exit command. Can I access that from outside? So yes, how can I access? Using port number, IP address now. So let me see that, which is the docker ps docker inspect command and container ID. And this is the port IP address, port number 80. I know. Curl HTTP. See, got it. So I can access from outside also.
Yes.
So these are the commands I run in order to go inside that and access the container from outside. Exit commands in IT mode, interactive mode. And this is the command will give you the IP address and access it. Understanding all of you?
Yes, sir.
Okay. So now there's a one more example I'll show you, that exec command power of it. So using exec command, you can run basically anything inside a container. So exec command, enter. What do you want? ls. It's inside a container. What do you want to run? df-kh. You want du-h. Everything inside the container you run, not in a VM. Mind it. So here we are
Yes,
saying,
sir.
hey, Docker, execute where? Here. What command? This command. But to go inside that, you need a IT. Right.
Yes.
Okay. So this is the way which you can use the container. So now what I taught you, first thing I taught you how to install the Docker. Then
Correct,
I
sir.
taught you how to work with the container. Then I taught you
Yes.
how to use the container. Okay?
Mm-hmm.
How to access the container. Now, next thing is, what are the other commands we have? So let me show you one page where I have noted down all the commands. And that is,
So we do get container images for everything, or we do not.
just a second, hold on. So here, this one will help you. So Docker command line reference. So in my site, lots of tutorials are there. You can try. So here, these are the command line reference. Yeah, now you ask me what was the question?
I mean, for example, I want to create a container for
Mhm.
uh, some application, let's say Spark. Do we
Yes.
get do we get that image?
Yes, every images you get it on hub.docker.com. Let me show you. Tell me the name of
Uh,
Spark, right?
yeah,
Spark.
am I
Spark.
right?
Yeah, see a bit name is Spark.
Okay,
Official image. So how do you pull same concept which I taught. Thousands of
okay,
images large. So you pull that and then run this. This is a Docker compose actually. Uh, how do you run it? Docker run. So here clone Docker build it. Build will develop an image. Where is run? They are not giving the tutorial for run. Here it is. Okay, what is run? I
okay,
am not explaining. You just give me some.
okay.
Okay. So now what to do? So I'll go by one all this command and see that. So attach command. So attach command will do what? So attach command will give you ability to attach to the container PID one. So let's say this is a container, right? Docker attach. See, you attach to the PID one. Okay.
Yes, sir.
Yeah. So there is nothing happening. So you're not seeing nothing. Okay. When you attach to that, when you control C, it will send the signal killing terminal, killing signal, and the container will get etched.
Yeah,
Okay. So
okay.
now after that, what? CP. Do you want to copy some files inside this directory? So let's go for Rajesh and oh, no, come on. So here, there's one file. Let's create raju.txt. Okay. Now this file I want to copy inside a container. So which container? So there's one container which is running here. But you know what? I'm not touching this container. Let me create one more container. So Docker create
Create.
HTTPD Docker start container and Docker. Yes, there's one container running. So I want to copy this file inside the temp of this container. So first I'll show you Docker exec, this container ID and ls tmp. So see, there's not our
We
problem.
should,
There's
yeah,
nothing here. So Docker
correct.
cp, the file name raju.txt, which
Docker
container?
name.
This container
Yeah.
colon path tmp. Copied it. See.
Yes, sir.
So this is the way you can copy the files to the container. Create a container
Okay.
I showed you. Any changes which you have done in the container you can see from the diff command. So for example, adding, deleting, updating and all stuff like that. You can see that. So I just modify raju.txt. I should see raju.txt. But here it's showing more than that. Why? So, oh, this is not a my
Our,
container. This
correct,
is the one. This is
correct,
the
correct.
so I modify raju.txt. So now you see that raju.txt you have it. Some of the extra files also has come because when you run some application, some additional files will be created. But this is the
Correct.
what I. So now this is the one. Exec I talked about it. Inspect I showed you. Kill I showed you. Pause I showed you. Port command, if you can see that if you're exposing the port number, then you can use the port command. So what,
Okay.
how can you use this? So let me explain you. So this container which you can see it here, Docker inspect and container ID which is here.
You have the spelling wrong.
Docker inspect. So this is the IP address.
Okay.
Okay. So here I can access that container from inside of the VM that is running, but I cannot access from outside this IP address. So what we do in this case? Let me visually first explain it to you, and then we'll talk about it. So if you see that this is your VM, I mean a laptop or VM, whatever it is, and then you are running a Docker here. Container is here, container is here, container is here. Each container also has IP address. But you know what? IP address is accessible only inside a VM. It's not accessible outside. You cannot do that. So what to
Okay.
do? So that is where that we expose the port. So this VM IP address is accessible? Yes. So when what I'm saying, port forwarding, you hit to here and then you can transfer the traffic, network traffic to here because here you have Ethernet.
Okay.
Got it? In a simple way, I'm explaining it to you. So how do you
Yes, sir.
expose the container to outside? Simple. -p option is being used. But before -p, I would like to talk to you one more thing, and that is one command which is called a run command. So what is a run command? So most of us are using run command only. So what is the run command will do? It will do the pull also, it will do the create also, it will do the start also, and it will do attach also. So four
Okay.
behavior it will do in one go. So these
Okay.
are the things. So you created a container, started a container attached to the process of the container and all. So that is a four commands you will do. Let's say if you don't want to attach to the container, so -d and do not attach. So like that. So now onwards, from now onwards, the I'll use
Run
the
command.
run command only. So how do I do that? Docker run
Okay.
httpd.
HTTP.
See
Yes.
here, I attached it. I lost the console. This is the Apache. Cancel. Container got killed. I want to do -d. Do not attach. I got the container. One container, two container, three container, and Docker
Yes, sir.
PS. See that here, so many containers.
Correct.
Okay, all are Apache running on the internally 80 port. So how can I access
Okay, sir.
this container outside? So you have to use the exposure Docker run HTTPD. You have to expose -p node port 8080 container port 80. I know. Enter. Now this consume my application. So -d also I will add it. Now, so there's one container which you have. You see that exposed. Only this container I exposed. What is the
Okay,
port
sir.
number?
80.
8080. So
Yes.
if you have a IP address, what is IP address? Here it is. And 8080. And see that this is the watch.
Okay, sir.
So this is
Oh,
the way you can also work.
okay, sir. I'll practice your commands and see what I can find out.
Cool. Okay, so
Okay.
now next thing is
I mean, we'll do it tomorrow because there is a lot of stuff that I need to practice, right? So,
mhm. Okay. So tomorrow onwards, I mean, what is this? Day after tomorrow onwards, we'll have
mm-hmm.
8 to 10. Okay.
Okay, sir.
So uh, be ready for that.
Sure.
And tomorrow we'll also complete the Docker because half topic is pending right now.
Yeah,
Okay.
sure, sir.
So there are few commands which is we need to complete this page.
Okay, sir.
Okay.
I'll do whatever you taught me today, and I'll wait for this video so that I'll
Mhm.
have as a reference.
Sure. Okay.
Okay, sir.
Then see you tomorrow.
Yeah, sure, sir. Thank you.
Yeah.
Thank you. Mhm.